Hi, Joyce.
9 instead of 8.
I
I
got
get the wrong one. Joyce, we're checking homework 9-1 to 9-3, talking about 9-4, and then being done and getting ready for a test on Thursday. Okay, 1.5, 25.6289, 1.5, a sub n minus 1. That's the recursive one, right? The recursive one is jumpity jump jump. And then we have the explicit one, which is n minus 1. Because 1 times is no big deal. Number next one.
22.
Ooh, he's right here. There's your r. There's your first term, 1/4. And there are a couple different versions of nth term formulas. How did they jump from this one to that one?
You bring the 1/4 in.
Yeah, because you can make 1/4 2 to the negative 2.
Mm-hmm.
Does that make sense? 2 to the negative 2 and negative 2 to the n minus 1. You just end up doing n minus 2 more. So n minus 3. Does that make sense? Number next one.
26.
Let's just
Graph. Does it look like it's converging or diverging?
converging.
Oh yeah. Number next one.
34.
Yeah, that one.
0.
Yes. Huh?
Right? Aren't the degrees
No,
tied?
that's 31. Never mind.
Degrees are not-
Oh.
Degrees are
Yeah,
not-
31's 3.
Sorry, I was looking at the wrong one.
No, you're okay. Number next one.
38. James Knowles.
0.
0.
Or K. Because R is 9/10, which is less than 1.
Goes above.
Remember, it could be 0.999999999, it's going to converge to 0, but as soon as it hits 1, it converges to 1, and anything greater than 1 diverges.
Okay.
Right? What's next?
44.
Question, what if it was
40.
negative
40.
1?
With what was, oh no, it would be diverging.
Because?
It's fluctuating between.
Yep, jumpity jump jump back and forth, back and forth. What's the only time that you can alternate and converge?
Plus 1 over n. No.
When they're decreasing or when they're getting closer and closer to a certain value like 0. Because it could go positive, negative, but if it's getting closer to 0, we're good. If it's getting closer, like farther apart from each other, or it's staying a fixed distance, we have to say diverges. 40. Diverges. Poor K, back and forth and back and forth and back and forth and back and forth and back and forth. Nope, divergent. Number next one.
44.
0. They technically said squeeze theorem, remember sine squared. Oh, we did this one.
Yeah.
Sine squared is between 0 and 1 over n, so 0. Number next one.
26.
Uh-oh. No. No.
Goes above. 46 is C.
Yeah.
You guys agree?
Yeah.
Above was there, but
I mean,
anyway.
that's just in case we
We
did.
could, we could always do this later and check our answers.
54E.
54 E.
Yes, 54.
Alright, we good on 9-1?
Yep.
Okay.
Yeah.
Let's go ahead and go to 9-2, and I'm getting there. Slowly but surely. I'm also getting the book open. But wait. Amanda, you had a couple questions on 9-1, didn't you?
Me?
Maybe not? Somebody did on
We
9-1.
did before, but it was just the sine.
Oh, the
squared
weird
one.
sine squared one? Okay.
Yeah. Which we ended up doing.
Alright, 9-2.
6.
Number 6.
I had to go to the hospital for this one.
Why?
La hospital?
Me too.
Oh.
1/4.
What?
I was like, that wasn't even a hard one.
Is that the right one? Am
I think so.
Dang it.
Maybe you wrote the wrong one down. That's possible.
Oh, no.
I didn't.
Because L'Hopital's derivative negative sine, negative cosine times u prime on bottom. You had to go again. Had to go again? No. Pi over 2 worked. You just have to take the derivative twice. Sine of 0 is, no, sine of pi over 2 is 0. Nope. Sine of pi over 2 is 1. Cosine of pi is negative 1.
Oh, I forgot.
Oh, did you create a u prime?
No, it's. I just don't know how to count.
Oh, okay. Number next one.
20.
Look at that jump. We like that one. 2.
What?
What?
I got
I
Ellen
got
too.
Ellen.
I got Ellen too. Wait, that might not be the end of it.
Yeah.
Oh, sneaky. Ln 2.
Oh wait, no, whatever. Oh, never mind.
Oh, shoot.
Ln of 2. Number next one.
24.
Okay.
1.
Oh.
I don't like these. These are confusing on.
I know
what
I
the
did this
answer
one
is.
wrong, but I got the right answer.
Yes.
Because well, check it, right? You set y equals to the limit, and then you take ln of both sides, and you move
Well, I
it
did
down.
that, it just, I thought ln of 0 was 0, but it's ln of 1 is 0.
Oh.
But I know I know.
Struggle. So you end up with 0, and then you can do e to the 0 is 1. Because
Yeah.
remember to solve.
I got one, but I was too lazy to go back and fix it.
Lazy bum.
36.
Alright, we got it. 36. You said do some, fun deriving. You had a quotient rule?
Yeah.
44, I couldn't do that.
That was disgusting and terrible.
44. But did you get it right? That's the
Yeah.
question. Aha! Go team. 1.
1.
Yeah.
Oh, I got 2.
How'd you get 2?
I don't know.
ln of both sides, cosine comes down, ln of cosine over cosine. Oh, over secant. What'd they do that for? Oh, because you need to make it over. Okay.
Oh, I see what it. I
And then
put
derivative
one over
secant,
cosine
secant,
instead
tangent.
of secant.
Hmm.
Oh, the tangents cancel,
I did
so
one over
negative
two,
1
too.
over secant, negative cosine. Plug it in, e to the 0 is 1.
Is that a song, Misty, by the way? Plug it in, plug it in.
It's a Glade plug-in commercial from, do they still do that one? Maybe not.
Oh, what?
Plug it in for Glade. No?
Is it a car thing?
Yeah. Could be, or just like in the house.
My sister sang it the other day, I was like, I didn't know this.
Yeah, it's a jingle. Like Lego My Eggo, but that's not a song. Did we get it?
Yeah.
Number next one.
60.
We did number 55 after.
Yeah. 60. The limit appears to be 0
We also do.
Oh, 55 was fun.
for letter A.
60, for some reason, it wasn't working in my calculator.
It looked like.
Oh, I didn't use a calculator.
It looked like they didn't agree. I
It
have
says
one.
use a graph.
I have one going in.
We're looking at the graph or looking at the table?
Graph. It's
Yeah, I looked at the graph and I got 0.
It appears to be 0, but the answer is truly 1.
What? I got 0 for the answer.
Oh wait, hold on. 0 over 1 is 0. L'Hopital is not applied. Oh yeah, you're right. It's 0.
See, I got 0 as the answer, but then I found the graph to be the end, so I just don't know how to read the graph.
Because what they're saying is if you had done L'Hopital's, you would have gotten the wrong answer.
No.
No, because cosine of 0 is 1, and then derivative at the bottom is 2, and 1 over 2 is 1/2.
No, that is after they derived it, because the original problem is, the limit as x approaches 0, 1 minus cosine x all over x plus x squared.
Oh, okay. So I'm saying it wrong. You can't do L'Hopital's again. You're
Okay.
done, plug in, and then you're ready to go. There you go. That's better.
The answer is 0, right?
Mhm.
Okay.
Yeah, the answer is 0. Sorry, I saw the bottom, but that was the denominator, so that has a limit of 1, not the numerator.
64.
So Amanda, was it just doing an error, or what was going on?
Yeah, I think it was just an error.
Oh,
It wasn't
shit.
working.
I see it.
Maybe radians instead of degrees. I don't know if that make a big difference, but
I will check it out. I don't have my count.
okay. Number next one.
64.
64, 55 was a question.
Yeah. we can go back.
64 should be C. I'm getting your e-text so we can just peek at the question real quick.
Yeah, that's fine.
Come on. Thank you. Okay. 64 is C. Final answer is 1. Do we have any more?
66.
66 was ln of 3 over ln of 2. Any more?
And then
Would that be ln of 3 halves, actually?
No.
Question? No?
No. There is no quotient property.
It has to be a big.
Oh.
There is no separate log, quotient, or product property.
I was thinking of ln of 3 minus ln of 2.
Right. And that'd be a single ln of 3 over 2. Sorry, I missed it. Any more evens, or are we good?
No,
That's all.
Okay, so let's go find number 55 and check him out, and that was chapter 9, section 2.
And if we can, we do 60.
Do you guys know the page?
458.
Okay.
Oh, it might be after that.
Yeah. Good call. Probably this page?
No.
Aha, there he is.
Oh, yeah. I got infinity, which doesn't make sense.
Hmm.
Ooh, as a piecewise function. You're welcome. Okay. And just for sake of organization, let me go here, let me go back to 9.2, is that him? Yes, and let's go here, and let's go here. Alright, number 55 says find a value C, which we are pretty used to, hopefully with the AP guys and the questions they ask, but things are a little different, because they say make it continuous. So, what has to be true for it to be continuous?
The limit coming from the left, coming from the right, and at C have to.
Exactly.
Yeah.
So I have to have C, which is the value at 0, equal the limit as x approaches 0. Which, if it's a limit as x approaches 0, I'm using the top piece, right? So I'll just say of f of x, which is the top piece. How do I take the limit of the top piece?
Do we have to do
Lower
separate
down.
limits or no?
Nope, just focus on him, because remember from the left and from the right, and this one is one function. It could have been defined less than 0, greater than 0, but this one wasn't, so I can just use the single function because it's both below and above.
Alright. And then just low details and keep going.
I think so, because they have 0 over 0.
3 times.
I did it 3 times and I kept getting I got
So the first derivative would be 9 minus...
9 cosine 3x over 15x squared.
Yeah, because I have...
x squared, let me,
I'm just not writing the limit, if that's okay. And the second one would be 27 positive, right?
Yes.
Yeah.
Sine of 3x.
Over 15x.
Next one would be...
81.
Yeah, and now that you're over 30, you're good to go. And that'd be 51? No, 81. Thank you, thank you, thank you, thank you. Cosine of 3x. Then there's an s. Struggle.
They were really knowing in their answer, they simplified that.
what'd you guys get?
27.
Cosine of 0 is 1, 81 over... Wait, 27.
Yeah,
Yeah.
you can divide
1,
81
3, 10,
by 3.
10.
Be 81 over 30 and you simplify it to 27
Oh, I didn't hear the over 10. I was really confused. I'm like, there's no way it goes in 27 times. Okay. Thank you, thank you, thank you. I was like, what? Dun, 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 dun. Alright, section 9.3. Boop.
We do 64.
Oh, sorry.
Alright.
64. It's on the next page. Come back to me. Think of me. Think of me. Okay. So, which of the following gives the values of... How'd you guys do it?
I just derived and plugged in.
I will derive. Okay. Because you get 0 over 0, right? So you could derive and get 1 over secant squared, which would be the same thing as cosine squared, right?
Oh, wait, what?
Because you were taking
I
a
like
derivative 1 over secant squared, and then that could just be 1 over cosine squared.
Yeah. I left it as
Plug it in, plug it in.
1 over secant squared, and I hadn't made my mental units calculating harder on myself.
Oh my goodness, yeah, you totally made it hard on yourself. That's okay. Still works. We got it?
Yeah.
Alright. Section 9.3?
Mhm.
Alright, let's go find it.
This is the one that I was doing, and I was just like so tired.
Oh, this is the 43. I started because I knew you did it in notes and I didn't want to have to redo it.
Oh yeah. I was like, I think I'm supposed to find the slowest one. So that's what I kind of.
Slowest one is for the, not the slowest one.
Most efficient.
Lowest
longer.
one. Yeah, the lowest one or the, yeah, I guess you could say slowest. Will be the most efficient. Alright, what are evens?
6.
Is this the right one? 2x squared?
No,
Hold on, is that, oh, that's exploration. Hold on.
I could have done it wrong. But
Yeah, that was.
There we go.
right
Haha, 0.
14?
14? Oh, he's right here. E.
Ooh.
Can you help me out?
Did you subtract the exponents?
I should have done that.
Or
Why
did you
I
think
do that?
of e
I
times
sense.
e to the x?
That makes so much more sense.
What did I do?
I LM'd it.
E is a coefficient.
I did something wrong here, Misty. I did e over x e to the x over e times e to the x. And I pulled out the e, but for some reason, I didn't pull it out as 1 over e.
Struggle.
It doesn't really matter, because I could just flip over the 1 over the 1 would be the same thing.
Yeah, because you were just comparing it with the top one on top, but either way.
But Misty, wouldn't it be E over E as the coefficients? So
Nope.
it'd be 1.
E over 1. Because he doesn't have the plus 1. He
But
does.
doesn't the plus 1 end up being insignificant? When it's to like the
Insignificant in the sense that their rates are tied,
Mhm.
but the limit is still a constant.
Okay.
Does that make sense?
Yeah.
Because it's the degrees are tied, so it's the ratio of leading coefficients, so E over 1 technically.
Gotcha.
18.
18. Final answer, x times e to the x wins, which you probably could have guessed. What else?
26.
Square root of x wins. Interesting. ln is pretty stinking slow.
32.
So far, so good?
Yeah.
We'll do 29 after.
Okay.
Unless we did it already.
Oh, 29.
What page is
I
homework?
had to re-erase so many times.
465.
Ridiculous.
Oh, and I definitely just guessed.
Slater showed me
But
the
I'm
way.
pretty sure I got them right.
Yeah, you're
I
supposed to
tried
just do it.
think which one would be stronger, and then I would try to compare those,
Mhm.
and then like.
It gets tricky,
I
right?
couldn't-
Yeah, Slater. What Slater did was smart. They compared one and the second one, and then they did the first one with the third one, and then.
Yeah, because you have
third
the
one
E
with
and the
something
L.
else.
I
Yeah.
figured ln of x would be the slowest, but then I was like, but it's to the x.
I would have done first and last, right? I would have compared those two.
I was.
Yeah, it was like 1 to 2, 1 to 3, and then like 3 to 4.
Because you could do e to the x over
Is that right? 1,
e to the x square rooted,
2,
right? We're trying to find the slowest to the fastest?
Yes.
Okay. So we could say this limit would be infinity, right?
Yes.
Because x over 2 would be a lower degree than x. So right now we can put,
Dx would, or
he would be faster. We'll just put him with a little check mark. He's the faster, he's the slower. And then we can have your x to the x, which technically, couldn't you do x over ln of x?
yes.
Mm.
Dang.
So you could have, in a sense, pulled the to the x out and thought of x over ln of x, which would be 1 over 1 over x. X is on top.
This thing got infinity to infinity.
Well, x wins over ln of x, right?
Yeah.
So that would be infinity to infinity, which would be L'Hopital's, technically.
No, because that wasn't an indeterminate form.
Infinity over infinity?
To the infinity.
Yes, it is.
What is it?
Yes, it is.
I think,
Actually,
isn't it?
no, it's
Anything to the infinity is.
0 to the infinity is indeterminate, 1 to the infinity, maybe not infinity to the infinity.
No, it's
How could infinity
it's
not-
infinity minus infinity, 0 times infinity, 0 to the 0, 1 to the infinity, infinity to 0.
Oh, sweet, so it
But
does work?
infinity to the infinity, wouldn't that just automatically be 2? Because if 1 is, 0 is.
But it does make sense, like infinity plus infinity is infinity, so infinity to the infinity, you're just getting a really strong infinity, you know what I mean? Whereas 1 to the infinity, it's not truly 1, 1, 1, 1, 1, because you're converging, or you're approaching, which is where the indeterminate comes in, same thing as 0. Huh.
Okay.
Yeah, that's one I would have thought was indeterminate also. So we can't just say infinity again, so then we can say that this guy wins over their battle. But now what do we have to do?
Check between those two and then.
Yeah, but check between, because we found the stronger and we found the weaker one, so we know at least roughly what that's going to be. So then we're going to have the limit as x goes to infinity of what do we got?
E to the x, so just e over x, and since e is a constant,
Wouldn't it be square root of e?
No.
Oh, it's e to the x, sorry, yeah. So,
E over infinity, so it goes to 0.
yeah, that's 0 to infinity indeterminate.
No, I'm saying, why, can't we just say Miss D, since it's a constant over infinity, it's going to 0? Oh, but it's 0 to the infinity.
Yeah,
never mind.
so that'd be indeterminate. Then we have ln of x over e to the x over 2.
And where'd you get the, oh. Where'd you get ln x from?
She derived, right?
Oh.
No, she didn't.
Although technically, couldn't we switch it then? Well, this is weird. Couldn't we do this every time? Because we could put x on top and e on bottom and infinity over infinity. No. Infinity to the infinity is infinity, right?
Yeah.
And Gerardo, you're sure you have all the indeterminate forms, right?
Yeah. I even looked online and I was like, what the heck?
Okay.
Let's check the book.
Then we would say this guy wins. And then this one we have 0 again, right? Because e to the x will win over ln.
Yeah.
So if we switch him,
You know, it was this section that made me stop wanting to say the word infinity. I got so tired of saying it.
Why would you say it?
because that would be infinity to the infinity is the infinity, so that means that he would win.
I'm just tired of it going off in my head.
So my guess would be, was it slowest to fastest? No, slowest growing to fastest growing. Okay, so then I'd have,
What? No. Mine has fastest to slowest.
doesn't it say slowest to fastest?
It says it right there.
What?
It says it
Did I
right
read
there.
the problem wrong?
Maybe Slater wrote it wrong, it's possible. Because you know how when people answer, they kind of do it their own way? Let's double check it though, I need to make sure it's right. That was 29?
Yeah, because I read it somewhere, I don't know. I'll figure it out.
That's really weird. Because infinity
Ooh.
is not indeterminate.
We're totally wrong.
I know, right?
Wait, what? What do you mean you're wrong?
You're way off.
Whoa, we didn't compare something. What didn't we compare?
We didn't compare e to the x and.
Oh, that was the problem. We missed one.
But we don't have to. Isn't that transitivity?
What's wrong with me?
If x to the x is stronger than e to the x,
Misty?
And e to the x is stronger than ln of x.
oh, but we didn't
Yeah.
do that one.
Which one?
E to the x to ln of x.
But we don't have to because x to the x is. Oh no, yeah, it's weaker, so we do have to. Never mind.
Because e is a
If
constant.
e to x was stronger.
Yeah,
then
we
would
left
have
that
to.
one off.
But-
Stink.
You could have done this in 3.
If we had gone in order, but I was trying to do like fastest, slowest, but I didn't. I just assumed. So we have x to the infinity, and we have ln of
Yeah.
x over e. That would be infinity. I'm just erasing all these. Okay, so now we have,
So
He's
e
stronger
to the
than
x
him.
Squared, then e to the x, then ln of x, then x to the x. Right?
and he's stronger than him.
Wait, e to the x squared is stronger than ln of x?
No, it doesn't make sense, right?
Yeah, because
Did I have
e
it
to
wrong the
x
other way?
would be stronger.
Because it'd be square rooted, so it's not to the x power. Do you guys see what I did wrong?
Yes.
If you pull out the x, then e would have just been to the 1/2. That's where I went wrong. There we go. Whew. Oh man, struggle. Because I didn't pull the x out of the e to the 1/2, so I got confused. Alright, so e to the x is stronger than e to the square root of x.
So we can
ln of x is stronger than e to the square root of x. X to the x is stronger than ln of x. So I know that x to the x is stronger than ln. Who is stronger than e to the x? Who is stronger than e to the x over 2? There we go. That should be right. I was pulling out the x, but I wasn't pulling it out of the e term. So then we have e to the good. Yeah. Sorry.
So we can just manipulate them so instead of getting,
We can see them as compositions of functions, and we can flip them to get infinity to the infinity, which we do know, as opposed to 0 to the infinity, which we're not guaranteed.
that's kind
Does that make sense?
of, yeah,
Yeah, I know, I don't like it either.
why don't we do it all the time?
Blah.
Do we do all of them?
Well, because usually when we're finding a limit, we're solving a problem given to us, we're not just answering a bigger question with whatever means that we can use.
Alright, 30, do we already do 30?
Nope, let's finish. 30.
32.
Oh, 32.
1, right?
F1 and F2 grow at the same rate, and F1 and F3, so everybody grows at the same rate.
And
I'll figure it out.
Is that it?
48. Sorry.
No, you're good. 48 should be E, final answer is infinity.
50.
50 you can already
is way
see
wrong.
is C, final answer is E squared, which you guys should see after that other one, right? Because the x plus 2 is e to the x times e squared, the coefficient is e squared over 1. Is that clear?
Yes.
Yeah,
Did somebody do, number 43?
I did.
Can I take a picture of
Yeah, you can read it.
Boop, e squared.
it? Amanda or Amanda, you guys do.
Which one?
Jordan, you scare me when you say if you can read it.
What number?
Because I looked at it, I was like, whoa.
43 we did in class.
Oh, okay.
Was that big one?
Yeah.
Do we have to copy it into homework, Ms. D?
Just get the idea. Just get the idea. You can like shortcut it.
I saw it was like one of those problems and I was like, okay.
Not feeling it?
Well, I feel like you do that on the AP
What
test.
did you guys get for 49?
Oh, E.
E.
No, yes.
Alright, section 9.4, we only have a few minutes, but let's just see where you guys got to. I'm gonna pull up the video really fast.
We literally
got to
got to
Gabriel's
the
horn.
very end and we were like, oh, what is the, what, like, where is she
Was
gonna
it Gabriel's
solve
horn? Was it that one?
Yeah, Gabriel's horn.
it? Like, we wrote down everything in the surface area, you weren't sure how to solve it, because we tried doing U sub, and it didn't work.
Oh, it needs trig substitution, and we didn't do trig substitution last year, so I wouldn't have been able to show them trig substitution.
Yeah.
Struggle! So we got all the way down, all the way down?
Yeah,
Let me see.
for the record, I said you should have done it way earlier, but we didn't in the end.
What?
talking about the
What's the
video.
point of the comment?
In the end, you got in the video you got as far as 2 pi limit as b approaches infinity, integral 1 to b 1 over x cubed times square root of 1 plus x to the 4th dx.
So you guys were on this one, right?
Yeah. Then you went ahead and said integration by parts.
Struggle.
Yeah.
Everything's freezing on me today. There we go.
Because it's cold outside.
Is it still cold? It's so
No,
warm in
just
my
kidding.
room right now.
I woke up this morning freezing.
Yeah, it was.
Like, getting out of the shower with little help. The cold help.
Okay, so then you guys got through that one. This one, Gabriel's horn, let's just go to the very end, see if I can zoom there. Zoom, zoom, zoom. And my question to you is, what arc trig would you use to use, or to solve? Use to solve, use to solve, right here?
I like using to
Using to use.
I
I was trying to use
All
some,
in the integral?
yeah, and it didn't work, right?
Which one would I have used?
Oh, did I zoom out and I was just talking about how it didn't work? Come on. Okay. Lucky 7.
All in the integral? Yes.
Ah. Alright, so what do you use?
Trig sub.
Arc sine? Nope. Arc tangent? Nope.
Trig sub.
Trig sub, so you have to take a picture of it. How would you use trig sub?
Well, the hypotenuse is going to be square root of x of 1 plus x to the 4th. That's going to be hypotenuse.
And whenever you have the squared and a plus, what trig do you end up trying to solve?
Don't remember. This is usually when I. Hold on.
So let's see, we're doing that problem for Gabriel's horn.
equals tangent theta.
Yeah. Because the plus is always tangent, because you have a squared plus b squared is c squared, so hypotenuse. There we go. So we could make a triangle. Pretend it's a right triangle. We'll just put a little right angle and say, haha. We can make 1 an x squared, right? And that would be our 1 plus x to the 4th. And we can do u is equal to,
X squared. Right? Yeah, x squared.
oh. Yeah. Hold on, let's undo that. We'll do tangent of theta is equal to x squared. We can say x over, well, hold on, then we need to do d theta, right? So we can say secant squared of theta. And who would 1 over hypotenuse be?
Secant.
Good. So remember, I'm just trying to fit it into whatever I can do. So over here, I can keep this guy, we'll just pretend he's there, plus x dx. I can move this 1/2 over. X dx can become, so x dx can become 1/2 secant squared of theta d theta. Why am I putting another secant?
Because secant
You said
cube,
it.
because of the tangent and
Yeah, good, because the 1 over is secant as well. So then I end up with the integral of 1/2 secant cubed. Ew, that's gross.
no, secant squared, and then do something else, and yeah.
Yeah, what can I do with secant squared?
The integral of secant squared is 10.
Tangent
Right?
squared plus 1, right?
Uh-huh. And then I could have secant times tangent squared plus secant. I think we have to do lucky 7 again, don't we?
Wait.
Love.
Because I think secant cubed is a lucky 7 one.
Oh yeah, it
I
is.
think
Yeah,
it is.
you gotta do it.
We've done it.
So we'd have to have secant,
Wait, hold on, let me find it, see if we can
Plus-
just skip there.
Thanks.
secant tangent squared. It might have been easier just to do trig sub from the very beginning. That'd be plus 1/2.
This D, this is one that she did tricks up on, she couldn't figure it out.
Secant of theta, tangent of theta, that'd be 1 over
Oh, that's right.
secant theta plus tangent theta
This D.
plus,
Here it is, back to this.
so at this point, are we gonna have to make secant tangent, v and then secant my u, isn't that right? Did you find it, Gerardo?
No, because it's on that paper that we had to turn in for tricks up. And I don't know where that is.
Oh, speaking of which, I think I got that from 2 of you. P.S. Are the rest of you just calling it a wash?
In the folder on
Wait,
Oh, okay. I'll have the TAs check it today.
The trig sub.
The trig sub worksheet.
I feel like I heard that in
You did.
I got Gerardo's and I got one other, and I forget who the person was because
It's not
I.
me.
Not you.
I'll tell you that much.
Oh yeah, yours is a wash. You were gonna work on it that one day and then you didn't.
Yeah.
With that u equals secant.
I ended up playing baseball.
Baseball.
At least a version of it.
Amanda Johnson turned it in.
Cool.
Devasarian turned it in. Jackie turned it in. But in the folder.
Ah, that's why.
Want me to just put it on your desk really
Yeah,
quick?
that'd be perfect.
Sorry, Miss Dean.
That's okay. Now I know where it is.
Can we put it in the iPad box or like next to the bottle or something?
put it on the desk.
I'll figure it out.
This one's a fun one, you see.
It's something. Because then we'd end up with, let's see, we still have that guy. Now we have this guy. Then we have plus 1/2 UV would be secant squared. Secant squared would be 1/1 plus x to the 4th
Oh,
minus
here it is.
b du.
I think it's this one right there.
Anyway, you guys can see it now, can't you? Because now I'm back to the one I just had.
Yeah.
So we just make that guy match and we would add to the other side, blah, 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 blah. Long story short, Gabriel's horn volume is finite. Surface area is infinite. Trig sub is what lets us see it. All right, cool kids, work on 9-4. I don't think I made homework that crazy. Did anybody start it over the weekend?
Yeah, I
Yeah,
did
it's-
all of it.
It's
I
fine. It's not that bad.
didn't like
16, 27, 39, 53.
And the nice thing is it's a big BC thing, in the sense that it'll show up on the BC exam, so.
Joyce, if you like this video, like, subscribe, leave a comment, description below.